You throw a ball straight up. 1 second later, it's 15 meters high. So after 2 seconds, it should be at 30. That's how lines work, right? Wrong. It's only at 20. The straight line rule just broke, and the shape that replaces it explains everything. Chapter 1. When the rate breaks. Here's the ball's height formula. h of t equals negative 5t squared plus 20t. Don't ask why yet, just watch it work. Let's track the height every second. At 0, it's still in your hand. Height 0. Plug in 1 second. Negative 5 plus 20. 15 meters. 2 seconds. Negative 20 plus 40. 20 meters. There's the point that broke our prediction. 3 seconds. 15 again, it's falling. And at 4, negative 80 plus 80. 0. Back on the ground. Now look at the jumps between the heights. Up 15, up 5, down 5, down 15. With the phone bill, that jump was the same every time. Here, the rate itself is changing. But watch the change of the change. 15 to 5, minus 10. 5 to minus 5, minus 10. Minus 5 to minus 15, minus 10 again. The rate changes, but by the same amount every second. That hidden pattern is the mark of a brand new kind of function. Chapter 2. That new kind of function has a name, the quadratic. Where does the bending come from? The square. So take the simplest version. F of x equals x squared. 1 squared is 1. Double the input to 2. The output is 4. Twice the input, 4 times the output. Double again to 4, and you get 16. 4 times bigger again. That's why the ball never reached 30. Now, a quick test. What's negative 3 squared? A lot of people write negative 9. But squaring means multiplying a number by itself. And negative 3 times negative 3 is positive 9. Opposite inputs, same output. So here's the full family. Every quadratic is f of x equals ax squared plus bx plus c. Match the ball against it. The number in front of t squared is a negative 5. B is the 20 in front of plain t. And C? 0. The ball starts on the ground. But one rule holds it all together. A can't be 0. Watch what happens if it is. The squared term disappears, and all that's left is 20t, a straight line. The square is the whole curve. Chapter 3. Time to see the shape. Take the 5 points from our table and put them on axes. 0, 0, 1, 15, 2, 20, 3, 15, 4, 0. Now, most people connect them with straight lines. You get a tent, and the tent is wrong. Because the rate isn't jumping at corners. It changes smoothly every moment. The real graph is a smooth curve through all 5 points. This curve has a name, the parabola. Ours opens downward, a hill, not a cup, because A is negative 5. And it's hiding a secret. 1 second and 3 seconds give the exact same height, 15. 0 and 4, both 0. The left side mirrors the right. Every pair balances around the same center, exactly halfway. T equals 2. That mirror line is called the axis of symmetry. And right on that line, the ball stops rising and starts falling. 2 seconds, 20 meters, the top of the flight. That turning point is the vertex. Chapter 4. Reading the graph. Because this curve answers real questions. First, how long is the ball in the air? Look where the curve touches height 0. T equals 0, the launch, and T equals 4, the landing. 4 seconds in the air. Those touch points have a name, the roots. Second question, how high does it go? You already know that point. The vertex, 20 meters at 2 seconds. Here's the good part. Every parabola reads the same way. Take f of x equals x² minus 4. A is 1, positive, so this parabola opens upward. The cup, not the hill. Now read it the same way. The vertex sits at 0, -4. This time the lowest point, not the highest. And the roots, where the curve crosses the axis. X equals -2 and x equals 2. Different function, different shape. Same 3 questions. Which way does it open? Where does it turn? Where does it cross 0? So that ball from the start? 15 meters, then only 20. And now you know exactly why. Next time, finding those roots without drawing a single point. Solving the quadratic. See you there.